Exercise, sports science, finance, and economics of sport, Module 5, time value of money. This module serves as a complement to Chapter 4, time value of money. Module Learning Objective 5.3. Solve a variety of time value of money problems using future and present value formulas, Excel, and financial charts. Future value. Suppose a sport organization invests $100 in a savings bond that pays 5% interest annually for 5 years. So what we would want to do is we want to find out what is the value of the investment after 1 year. So you would take the original investment of $100 plus the interest, and that gives you the future value. So here it's pretty straightforward. It's $100 plus 5% multiplied by 100. That gives you 105. Now we get into the argument of simple versus compound interest. Simple interest is only calculated on the principal, whereas compound interest is calculated on the principal and on the interest generated by that principal. In other words, it's interest on top of interest on top of interest. So the formula that we're going to look at with regard to the value of an investment under compound interest requires the following formula. Future value equals the present value multiplied by 1 plus the interest rate raised to the number of periods. And it looks like this. So FV equals future value. PV is the present value of the initial investment, otherwise known as the principal. I is the interest rate, and N is the number of periods. So the one great thing about this module is that there are going to be 3 different ways that you can solve each of the formulas and each of the problems. So you could do it a couple of different ways. So we're going to do the formulas here and using the chart, but you can also do Excel as well, and there'll be another video to show you how to solve for time value money problems in Excel. So let's start off simply with the formula and the charts. So suppose a sport organization invests $100 in a savings bond that pays 5% interest annually for 5 years. So the formula is pretty straightforward. Future value equals present value multiplied by 1 plus the interest rate raised to the number of periods. So I'd like to diagram the problem out. So our present value, PV, is 100. Our interest rate is 5%, written as a decimal, 0.05. And the number of periods is 5. So when we plug that into the formula, our answer is going to be $127.63. Now, as I mentioned a few moments ago, you can actually solve for these problems as well using charts. So in our course textbook, there is something called the time value of money tables in the back of the book on pages 632 to 639. I also put copies of these tables in our Canvas site in this module. So what we would do here is we would use Appendix A.1, future value of 1 at the end of n periods. And we would do a cross-reference between the number of periods and the interest rate. And when you would look on the chart, you're going to see 1.2763, and you multiply it by 100, and that gives you $127.63. So you can solve for future value problem using the chart and the formula. Let's talk about annuities and perpetuities for a moment. The value of an investment is paid out or received not in one lump sum, but over time in multiple payments or receipts. Any series of equal payments or receipts made at regular intervals is termed an annuity. I like to call it a series of equal periodic payments over a specified period of time. Now, annuity payments may occur annually, quarterly, monthly, or at any other regular interval. And here are some examples. A mortgage payment, an individual retirement account, otherwise known as an IRA, when you make a contribution to them. A loan and pension payments, all perfect examples of annuities. An annuity has a scheduled ending point. You know when it begins, you know when it ends. However, there are times that there's a perpetuity when those payments or receipts continue for forever. Now, perpetuities are rarely established for obvious reasons because forever is a long time. So, we're going to really focus on annuities, and that is a series of equal periodic payments over a specified period of time. Now, let's look at the future value of an annuity. So here is our formula for a future value of an annuity. FVA is the future value of the annuity. PMT is the payment. I is the rate of interest per period. N is number of periods. So it's payment multiplied by 1 plus the interest rate raised to the number of periods minus 1 divided by the interest rate. So let's look at an example. A sport team might need to determine how much money it would have after investing $1,000 per year for 5 years at 5% interest. So the reason why we know this is an annuity, it's a series of equal periodic payments over a specified period of time. It's $1,000 a year for 5 years. That's why it's an annuity. So we plug it in. So the payment is 1,000. Our interest rate, we're going to write it as a decimal, 0.05. Our number of periods is 5. So when we solve for it, it comes to $5,525.63 using the formula. Luckily, as I mentioned previously, we had the time value of money tables in our textbook, pages 632 to 639. But I also put copies of them in our module for this chapter. Appendix A.2, we would use the future value of an annuity of $1. And when we would cross-reference the number of periods and the interest rate, we get the number 5.5256. We multiply that by our payment number of 1,000. And as you can see, we are relatively close. 5,525.60 with the charts, 5,525.63 with the formula. Just a rounding situation. Let's look at another example that is multifaceted, and I think it's a good one to look at. So you have two sport managers. They open retirement accounts and commit to invest $3,000 each year, earning 7% interest until they retire. The first sport manager starts investing at age 25 and continues until age 65. The second sport manager starts at age 35 and invests until age 65. So let's look at the first sport manager first. So we know it's an annuity because they're going to invest $3,000 each year. In the first sport manager's case, it's going to be for 40 years. In the second sport manager's case, it's going to be for 30 years. So equal periodic payments over a specified period of time. That's why we know it's an annuity, and we're looking for the future value of it. So we go back to our future value of an annuity formula. Payment multiplied by 1 plus the interest rate raised to the number of periods minus 1 divided by the interest rate. So our payment's 3,000, our interest rate 7%, our number of periods is 40. We plug that into our formula. Our final answer is going to be 598,905.34. If we were to use the charts located on pages 632 to 639, and we're looking at Appendix A.2, the future value of an annuity of $1 chart, we're going to look at 7% and 40 periods, cross-reference that, and we're going to get the number 199.6351. Then multiply that by our payment number of 3,000, and that gives us 598,905.30. Once again, maybe a little bit of a rounding issue, but we're all good. Now let's look at the second sport manager. So same setup. The only difference is instead of 40 years, we're doing 30 years. So same basic premise. If we use the formula, the payment is 3,000. The interest rate is 0.07. The number of periods is 30. and we should get 283,382.36. If we were to go use the time value of money tables in our textbook, we would use Appendix A.2, future value of an annuity of $1. And if we were to cross-reference 7% and 30 periods, we're going to get 94.4608 and multiply that by our payment number of 3,000, and we get 283,382.40. Let's shift gears into the concept of liquidity. Sport managers must understand the significance of liquidity before investing capital in any project. An asset's liquidity is the readiness with which it can be converted to cash. More often than not, organizations own assets, particularly like real estate, that cannot be easily sold to raise cash to pay short-term obligations. We talked about this concept when we looked at the module on financial ratios, particularly when we looked at the current ratio and the acid test quick ratio. Before committing to long-term investments, individuals and organizations must understand the importance of maintaining liquidity. If you cannot effectively meet cash obligations, you might be forced to sell assets, file for bankruptcy, or alter short and long-term financial commitments. So liquidity is important here. Let's look at an example. Let's kind of put it into a better frame of mind. So we're a recreation center, and we have $20,000 in cash. We want to make a capital improvement. We want to add a basketball court. So we're going to make a $9,000 commitment to this capital project. The ultimate goal is to generate increased participation fees from the new basketball court. So as a result, the recreation center is less likely to use an additional $9,000 for another project with similar expected return. So, truth be told, they don't want to be left with only $2,000 in reserve for short-term obligations or emergencies. That's why they're only going to invest in the one basketball court. Any second project would not only require a high return on investment, but also return cash within 1 to 2 months. So, even though the cash on hand says you could do it, reality says you shouldn't do it. Let's talk about present value. So with present value, sport managers must understand the concept of present value. Present value is today's value of a future cash flow, the current value of a payment that will be received or paid in the future. We calculate present value by applying a discount rate to the future cash flow. Now, when we're talking present value, that is critically important, the concept of a discount rate. The discount rate is a measure of risk or uncertainty. Now, remember from the previous video in this module with regard to Shohei Ohtani's contract, we talked about the discount rate and we talked about the present value of that contract today. So let's look at the present value formula. It should look a little familiar to you because essentially it's the future value formula just inverted. So present value equals future value multiplied by 1 divided by 1 plus the interest rate raised to the number of periods. PV is the present value, FV is the future value, I is the discount rate per period, and N is the number of periods. So let's look at an example. Okay, so remember how we started off the module talking about this concept of you have an agent, and the agent provides you with a multitude of options in terms of how you get paid. So let's revisit it. Your agent asks if you are willing to accept $120,000 payable in 3 years. For arguments of this example, let's assume a 6% discount rate. So how do we calculate the present value? We have two options here. We can use the formula or we can use the charts. So let's do both. Okay. So if we do the formula, our future value is 120,000. That's what we know it's going to be worth in 3 years. We know it's a 3-year period, and we know our interest rate is 6%. When we plug that into the formula, we're going to get 100,754.31. in terms of what our present value is of this deal. Now, the other option is we can use our time value of money tables in our textbook, pages 632 to 639, and we're going to look at Appendix A.3, present value of $1 due at the end of end periods. We're going to go to that chart. We're going to look at 3 years and 6%, and we're going to pull up the number 0.8396. We're going to multiply that by our future value, which is 120,000, and that gives us 100,752. Now notice there's a little bit of a rounding issue, but it's okay. You might see anywhere between a few cents to maybe a couple of dollars, but that is the generally accepted range with regard to using the chart in comparison to the formula. So let's look at another present value problem. A minor league baseball team anticipates sponsorship revenue of $15,000 to be realized in 4 years. For purposes of this problem, let's assume a 9% discount rate. So what's the present value? Same thing. I like to diagram out the formula in the whole problem. So we know what our number of periods are, 4. We know our interest rate is 9. We're going to write it as a decimal, 0.09. And we know our future value is 15,000. So after we diagram it out, and then we plug it into our formula, we should get 10,626.38. The next thing we can do, we can use the time value of money tables in our textbook, and we're going to use Appendix A.3, present value of $1 due at the end of end periods. We're going to cross-reference 4 periods at 9%, and we're going to get 0.7084. We're going to multiply that by 15,000, and that gives us $10,626. Notice the rounding, very slight rounding difference between the formula and the chart. So now let's shift gears and talk about present value of an annuity. So here is our present value of an annuity formula. Payment multiplied by 1 minus 1 divided by 1 plus the interest rate raised to the number of periods divided by the interest rate. So we break it down, PMT, payment per period. I is the discount rate. Very important we identify it as a discount rate. When you are dealing with present value, time value, money formula problems, I is the discount rate. And then we have N is the number of periods. So a sport manager might wish to determine the present value of a series of cash flows. Let's look at an example. All right, an agent negotiated a long-term sponsorship deal that called for yearly payments to an athlete of $10,000 for 5 years at a discount rate of 10%. We know this is an annuity because it's a series of equal periodic payments over a specified period of time. We know it's a present value of an annuity because the reference to a discount rate. So it's very important that we pick up on the vocabulary that is used in these problems. So let's break it down. Like I said, I really like to diagram out the problems. Yeah, I find it to be a lot easier to see everything. So we know our number of periods is 5. We know our interest rate is 10%. We're going to write it as 0.10. We know our payment is 10,000. That's going to be our annuity. We want to know what the present value of this annuity is going to be. We plug it into the formula. We're going to get 37,907.87. Luckily, we can also use the present value of an annuity chart. So we can go to our time value of money tables in our textbook or on our Canvas site because there are 4 of them there for your use. We're going to go to Appendix A.4, present value of an annuity of $1 per period for n periods. And then we're going to cross-reference 5 years at 10%. And we're going to get the number 3.7908. We're going to multiply it by 10,000, and that gives us $37,908, which basically says our long-term sponsorship of $10,000 a year for 5 years at a discount rate at 10% is presently valued at $37,908. Or if you use the formula, $37,907.87. Now, the other thing we have to look at is interim year compounding. In many financial arrangements, interest can be compounded each quarter, month, week, or in some cases by day. So, a sport organization wishes to determine the future value of $1,000 invested for 2 years, receive 12% interest compounded quarterly. So, when we see the words compounded quarterly, almost immediately we know we're going to have to make an adjustment to our interest rate and number of periods. And once again, that's why I like to diagram everything out. So if we look at it, so we're dealing with a future value formula. Future value equals present value multiplied by 1 plus the interest rate raised the number of periods. But if you look at how I diagrammed everything out, so present value is 1,000. Look at our interest rate. Write it as a decimal, 0.12. But due to the fact that it's compounded quarterly, which means 4 times during the year, I'm going to divide the interest rate by 4, which gives us now 0.03. And now that it's compounded quarterly each year, we're going to take 2 times 4, which gives us 8 periods. So that's where we're going to make the adjustment. So hypothetically, if this were semi-annually, we're going to divide by 2 and multiply by 2. If this is monthly, we're going to divide by 12 and we're going to multiply by 12. So the key thing that we have to look for, we're going to assume annual interest unless otherwise instructed. And in this problem, we're being instructed to say that it's compounded quarterly. So our future value is 1,266.77 with the formula, and then we can go use our time value of money tables, Appendix A1, 8.1, future value of 1 at the end of n periods. We cross-reference eight periods and 3% interest, we get 1.2668. We multiply it by 1,000, and as you can see, we get 1,266.80, which is a little bit of a difference from our formula. Congratulations, you have successfully completed Module Learning Objective 5.3. Solve a variety of time value of money problems using future and present value formulas, Excel, and financial charts.